Hey, in this video, we're going to go through how we would solve the last type of elimination problem, which is when neither coefficient really goes into the other, and I have to multiply both equations by a constant. Again, when I go to do this, it doesn't matter which I eliminate, x or y. It boils down to personal preference. The thinking when we do this, though, is going to be very similar to when we were adding fractions, because we want to make those numbers the same but opposite. So as I'm looking at this, I have 3 and 5 for my x's, and I have 4 and 9, or negative 9, for my y's. Just out of ease, I'm going to eliminate the x's. Again, it doesn't matter which one I choose. So what I need to do is I need to turn both of those x's in both equations into the same value, but with opposite signs. So the first time that 3 and 5 go into the same number is 15. I also need one of those equations to be one of those 15s to be negative. It doesn't matter, so I'm just going to choose the bottom equation. So what I'm going to do is I'm going to multiply the top equation by 3, so I will have a positive 15, and I'm going to multiply my bottom equation by negative 5, so again, the coefficient of x is negative 15. What this is going to turn into is I'm going to have 15x plus 12y is equal to 90. I'm going to have negative 15x plus 45y, and I need to find a calculator, so I can do 8, I think that's 90. I'm still going to double check on a calculator. Yep, okay, so it's going to be 90. And it's negative 18 times negative 5, so that's why it's a positive. Now, from here, it is going to be the same thing you've seen in the previous examples. I'm going to add my two equations together. When I do that, the x's cancel out or eliminate. I would do 12y plus 45y, and I'm going to get 57, and that is going to be equal to 180. Okay. Let me make sure I wrote this problem down right. I did not, in fact, write this problem down right. That's okay. So from here, what I would do is I'm going to divide both sides of my equation by 57. When I take 180 divided by 57, I'm going to get a crazy never-ending decimal. And again, the reason why this is happening in this problem is because I actually forgot to write down a negative sign, so is what it is. Now, once I have my y, I'm still going to go back, plug it in, and then solve for an x. Again, it doesn't matter which equation I choose. Choose one of the original two, so you don't have to deal with a 45 or 15 feels a little bit too big. So let's do the bottom equation for something different. I'm going to have 3x minus 9 times, again, my 3.158. And that's equal to negative 18. I would then go and solve this equation. Three times, 9 times 3 point whatever is going to be 28. I would then go and I would solve this two-step equation. Now, in my work, I want you to notice I'm getting lazy with writing that decimal. On my calculator, I am not doing that. I would divide both sides by 3, and we would get x is equal to 3 point some decimal. And then to finish the problem, what I would do is I would write this as a coordinate pair Okay, and there would be my solution. Again, what you are seeing happen between all the different examples of elimination, what we want to do every single time is add the two equations together such that a variable eliminates or cancels out. If I cannot do this, I am multiplying one or both equations by a number to make that happen. Now, what is important is that the coefficients are the same value with opposite signs, and it doesn't matter if I eliminate x or y first, you get to the same place. In this problem, a couple of the choices I made was I decided to eliminate x's just because. In addition, because both the 5x and the 3x were positive, one of them had to be negative. It didn't matter which one of those numbers was negative. I just chose the bottom one to be negative. If you are looking at a problem and you're like, hey, am I going to make the wrong choice? No, it doesn't matter. It's all going to work out in the end. But this is about the most complicated of an elimination problem we can have. I guess you could make it have no solution or infinite solution, but if that was happening, both the x and y's would cancel out after you did the first part. Otherwise, if you're looking at this and you still have questions, please be sure to let me know. And again, this is how we would solve a system of equations using elimination.